Hello, everyone. Good morning, afternoon, or evening, whichever time zone you may be calling us in from today. Thank you for joining. My name is Rebecca Cronin, and I'm one of the customer success managers here with the Altair Data Analytics team. The customer success team is another point of contact for you to reach out to at any time with any questions, concerns you may have regarding Altair solutions, as well as if you're unable to get a hold of your account manager. So a little housekeeping. You will see the control panel. There is a handout section. It is a copy of today's PowerPoint slide deck for your reference. It does have some helpful web links for AI Studio resources and AI Hub. You'll also notice there's a question panel where you may submit your question at any time during the session. It does not have to be about today's topic. It could be anything related with AI Studio, AI Hub. We will do our very best to answer those questions during the session, and if we run out of time, we will follow up directly with you. Allow us 2 to 5 business days to get back. If you do submit a question and you want it to be addressed in private, offline, please make sure to put that comment when you submit your question. So for no further ado, I'd like to show our starting topic is to be model optimization hyperparameter tuning. Our expert is Jeff Chowaniec. He's one of our senior data scientists. He's worked for almost 10 plus years in various technical support roles, that including of Altair RapidMiner. Jeff was our original RapidMiner specialist, and we're fortunate to have his expertise. He leads by example by providing tremendous assistance to both our customers and our own internal teams. Some of you might have even had the pleasure of working with Jeff. So with no further ado, I'm going to make Jeff the presenter, where we'll dive in to our topic. All right, Jeff, switching it over to you.
All right, good morning, everyone. Just want to verify, Rebecca, that my AI Studio is showing.
Yes, I see that interface.
Perfect. All right, so I'm going to be talking about model optimization today. So we'll be using kind of a handful of operators, and I'll try to touch on a lot of stuff related to it. So let's say we have a data set. So I'm going to just grab this really quickly. Maybe I'll grab it from the samples folder. That's probably easier. Data. Just make sure this works. This looks good. Okay, cool. So maybe we've gotten to a point where we've built a model. So maybe I'm doing something like cross-validation, and I'm in here and I'm using a just really simple decision tree and saying, hey, take this, learn, train me a model, and get me a performance output. Spelling really gets me every time. And I'm just saying, hey, let's apply this model. Let's get a performance output and quantify how good this model is. Maybe I've trained a couple models in AutoModel or use AutoModel to figure out what learner I want to leverage. But in this case, I'm here, I've trained a model, I get a performance output out, and I'm just using the default parameters. So when I run this, I should get out a decision tree. I've got my training data there, I've got my decision tree here, I've got my performance vector here. Now, I'm using the default parameters of this decision tree. For example, maybe I want to change my criteria, my maximal depth, my confidence, if I want to enable or disable the pre-pruning options, what have you. I could start altering this. I could say, let's do a depth of 15 and let's crank up the confidence to 0.15 maybe instead of 0.1. And then I could run this and see, okay, well, my performance went down. I could keep tweaking this forever endlessly. But what I want to do is automate this process. I want to decide, okay, well, here's the combination of options that I want to optimize, and I want you to try all of them. So there are a couple of options for this, but basically what I'm going to do is take this cross-validation and put it inside of an optimized parameters. You're going to see that there are 3 flavors for this optimized parameters. There's a grid, a quadratic, and evolutionary. The 2 I'm going to focus on, and I'm really just going to be focusing on the grid, but we'll talk about evolutionary and I can show it off as well. But they allow me to essentially select parameters in the operators that I have and allow me to try a bunch of combinations and then output the combination that gets me the best possible model. So I could throw something in like my cross-validation here that I'm training, and then for my optimized parameters grid, I don't want this output though. And then in there, I think I connected stuff I don't need, like that one. But in here, basically, I can say, here's this edit parameter settings. And I can say, all right, well, let's grab my decision tree. And then the ones I care about are like my maximal depth or my confidence value. So I can select these 2 parameters, and my optimized parameters grid allows me to make a list. That's kind of the grid, right? I'm going to say, do a depth from 5 to, I don't know, 20. And then we'll do that in, what should that should be like 14 steps to go from 5 to 20. I think that looks good. I'm missing 12, so I think it's 15 steps. There we go. That looks good. It's linear. I can change this from linear to quadratic to logarithmic. In this case, I just want to go 5, 6, 7, 8, all the way up to 20. So linear scale works great here. Now, in order to create that tree or that grid, I'm going to also take my confidence. In here, RapidMiner will do a good job, or AI Studio will do a good job of identifying like the minimum and maximum for a variable. So if something can go from negative infinity to positive infinity, it'll let you know that by the defaults. In our case, we can't have a minimum confidence of 0, so it gives me a number so small it might as well be approximated as 0. So that's why I don't have a 0 in here, because I cannot put 0 in for this value. It will break my workflow. For our case, I could throw in, we could say from 0 to 0.5, 10 steps, we go 0 to 0.05 to 0.1, and this looks good. I don't think I'm going to change that, so I'll hit OK. So that effectively creates my grid, and we will see this if I use this log performance checkbox as well. But essentially, I'm saying train a whole bunch of decision trees to solve the question of what parameters are going to generate the best model based off of the accuracy from my cross-validation. So there are a bunch of branches I want to go down, pun intended for the decision tree, but there are a bunch of branches I want to go down with this operator, because there's actually a lot more than we can do with this. And this is kind of the basic usage of this operator. But if we look at our parameters grid here, you can see what our grid looks like if I sort by iteration, because you can see here's our confidence starting value, and then we run through all of the maximal depths that we could use. And then I move on to the next confidence value, and I move through all of those. And you can see I try every combination. So that's the grid part of our grid-based optimization. I could sort by accuracy, and we could see what the best combinations are. The most important part of this is I've generated, if I sort by iterations here, 176 different models. This was pretty easy. I've got a lot of RAM, a lot of CPU capability here. So I was able to parallelize these. And as you saw, if I press play here, this runs fairly quickly, generating all of those decision trees for me. But as I add combinations to this grid, I'm going to be training more and more models. So for example, if I jump back to my grid and say, you know what, I want to also add in my criteria, and in here, this one is a list, so I can choose each one of these that I want to run. I think I want to remove least square because that's if I'm trying to predict a number. And then I can run this. You can see it's not instantaneous, but it still runs fairly smoothly. If I press play from here, you'll see all of these combinations. So I add in an extra column for my decision tree criteria, and then I can see my depth and confidence change because the Gini index with 5 and 0.5 for my confidence gets me the best decision tree. So I can see what that decision tree looks like. It's actually a pretty decent tree for the excuse me, for the Titanic data set. Very generic. I'm actually pretty happy with this tree. That's besides the point. But I can see my accuracy, etc. So what I'm doing now, and this raises a bunch of other questions, is how many things can I throw in here? How many parameters can I edit? And so I can keep throwing stuff in here with my grid-based optimization. The thing is, I'm going to be creating more and more models. So for example, I could do minimal leaf size, minimal size for split. I could keep throwing stuff in here and say my minimal leaf size should be like 5 to 10. That should be, I think, 5, 6, 7, 8, 9, 10. I think is it 5 steps? Yeah, 5 steps should work. And then minimal size for split, I could do like 3 to 7, and steps can be 4. So I can keep adding combinations. You'll notice this will keep adding execution time. So if I go to the results view, this one isn't going to run instantaneous. And I'm going to be creating more and more iterations as we go. So I can quickly balloon this. Anyway, the idea is be careful with this operator, especially the grid-based optimization, because it is going to build anything. There is no stopping mechanism for if overall accuracy hasn't improved with a given set of combinations to stop trying new combinations, right? There's no stopping mechanism for this. I told it to deliver if I tell it to deliver 1 billion combinations, it's going to train 1 billion decision trees for me. As you can see, I've quickly gone through 7,000 iterations. So if I made 1 billion combinations, we'd be here for a while. You'll start to hear your CPU kind of go wild, and it'll start to sound like your machine is about to take off for outer space. But there's no stopping mechanism, which brings up the question of, grid-based optimization is great when I've got a general idea of where these values should be. Now, I could also change this and say, maybe I want to replace this operator. I'm actually going to, I'm going to disable this for now. I'm going to copy and paste, and I'm going to make some changes. But let's say we have an algorithm that we don't necessarily know what the values should be. So if I disable this and use something that's a little bit more of a black box, where if I go like gradient boosted trees instead, where I've got my same maximal depth here that I can configure. But I also have other stuff like my learning rate and my sample rate, where these kind of govern and they affect if I stick around in a local minima. I don't want to be trapped there for too long. So my learning rate kind of helps me get out of those local minima. But I don't necessarily have an idea. Like when I select a maximal depth on my decision tree, I know that a depth of 15 is going to create 15 splits, but I don't necessarily have a physical idea of how learning rate is going to affect this and where this value should be. I can look up where it should be in the distribution and learn more about the learning rate. But at the end of the day, this is probably a better variable to stick in my optimized parameters evolutionary. So I could change this out if I right click and just do replace operator. I'm going to go to modeling, optimization, parameters, and then switch it over to evolutionary. It's going to yell at me. Replacing operators like this isn't going to be perfect every time, but it needs the performance. I'm going to send my model object out, and then I want to look at what those parameters are. But this actually has a stopping mechanism. So I can select a max generations, population size, mutation type, tournament fraction. But the idea here is if I select these variables, I'm going to remove this. Okay, I'm going to edit these parameters again. I'm going to select my gradient boosted tree. I could select my maximal depth here, so I can give it a min and a max. I'm going to say 3 to 10. And then if I grab something like my learning rate, I can say, all right, well, we're going to start small, and then we're going to ramp up, but I don't want a learning rate close to 1. So we're going to go to like 0.2. And we're just going to let the evolutionary grid do its thing. And I can enable early stopping. Generations without approval, I'll say, let's be generous and do like 5 generations. And we don't actually see any improvement. So instead of optimizing this forever for all of those combinations, I can just say, hey, here's a minimum, here's a maximum, train a whole bunch of models for me, and then stop when we don't see any improvement on those combinations. So this will do its thing. It's going to build me a bunch of decision trees. These take a little bit longer to run than the gradient boosted trees, so I might be here for a while. But again, I'm looking at variable combinations, and I'm saying, hey, if we are trying stuff and I don't see approval, if I don't see any improvement in the performance of these models after a while, I want you to go ahead and stop, because we've kind of hit a well that of parameter combinations that is generating me the best possible model. So this is great when I don't have an idea of where those parameters should be, and I don't want to create billions of combinations of parameters and sit here forever letting it run. I want to just do some fancy math and let it do its thing. So this is kind of the main bifurcation of hyperparameter options. Going the evolutionary route, if I don't know what, if I don't have an inkling of what to do with those variables, this is how I leverage this. Is I generally will throw it into an evolutionary to get a ballpark, and then maybe toss it into a grid after that. But the main purpose of both of these is to generate a parameter object for me. And what I'm going to do is I'm going to just do, I was hoping this was going to run a little bit quicker, but I maybe should have reduced down the generations. Oh, speak of the devil. So this ran, it gave me a depth of 5, a learning rate of about 0.19. And so now I've got this parameter object set. So what I could do, if I store this object, so if I come over to my parameter set, I could store this. So I could store a parameter set in my repository. I'm just going to throw it in my testing folder really quickly. Parameter set. And now I can actually use that object. So if I disable this operator and say, okay, well, I really like that gradient boosted tree. We know the performance of that because we got it from our optimization. So I'm going to say gradient boosted tree, and then I'm going to go to my repository, and I'm going to go to my testing folder and grab that parameter set. And then I'm going to say apply parameter. or set parameter rather. I'm going to grab my set parameters object. I'm going to say go in there, and I'm going to send my training data into my gradient boosted tree. And I'm going to make sure that this operator runs before my gradient boosted tree. So I'm going to say edit list, set operator name, control C, and I'm going to say set gradient boosted tree 2. And if I run this, I should get a model out. I should now get a trained model using those parameter options. So this is actually the key component here is I am generating this parameter set so I can apply it to the models. So now I can send all my training data in. I'm using those parameters that I've set here from my parameter set. So if I output this really quickly, I just have my parameter set here. It just tells me to set the depth to 5 and the learning rate to 0.18, and then I am good to go. So I can just leverage that parameter set that comes out of the hyperparameter tuning. The way I like to really do this in theory is if we're doing a lot of model testing, is I really like to use stuff like a branch operator in here. And we do like a set macro, for example. So we do set macros, or we can put this in the context panel, but I usually like to say optimize, and then this is 1 or 0. So then my branch operator will just be an expression, which is %, curly bracket, optimize. Spelling really gets me every time. Equals 1. So when optimize right here is 1, we're going to run this side of the branch, which means we're going to run this control. I'm going to do the grid-based optimization. So we'll run the grid-based optimization. So we could throw this connection in, and it's going to do my grid optimize, and then I'm going to get my parameter set out, and then that parameter set is going to get piped into, is going to get piped into this set parameters operator. So it's going to go in there, and then I'm going to send my training data out as well. Actually, I'm just going to use a multiply operator up here. So I'm going to send that in here. Then my set parameters will give me that option out. So that way I can control whether or not I need to re-optimize this operator. I'm going to need my decision tree here. And that should be good. I just need to change this to DT. And I need this operator name. There we go. And if I edit that optimization, I can come in here. I'm just going to remove these guys because they make stuff run a lot slower. So now if I run this expression, maybe I need the eval function in here. Oh, it's not running in the right order. That's why. Execution order matters. There we go. Okay, so now that macro should get created. And what you'll notice is my branch runs and it kicks off the optimize. It stores those parameters for me, and then the set parameters will deliver those parameters to my decision tree. So if I do like a depth of 100 here and I run this, my optimize is going to give me those parameters, and I should see not a depth of 100. What did it select for my parameters here? Oh, it selected a depth of 16, so this one's a little bit bigger. My old parameter set. So it's there, but if I go to set macros, actually, I can test this easier because I'm not sure I'll get a depth of 100, but we'll do like a depth of 4. If I go to my set macros and edit this, I can just say 0. So that way it won't run my branch. What I need to do is actually put this inside of my branch. Oh no. So now if I run it, I get the really small one. So I've just set up a macro control to decide whether or not I optimize. You can see my decision tree is really small. I don't have a depth of 16 here, which means it's not using those preferred parameters. So enable this. I could have other triggers, so I could look for a parameter set, etc. These are cool things that I could add in, like whether or not I want to optimize in my model training process, especially if I've got a use case that requires me to retrain my model often due to model drift, then I can add in some controls to decide whether or not I want to optimize or how frequently do I want to optimize. It could be a manual control, it could be an automated control. I could have the branch kick off if the parameter object in my repository exists. So I could say, hey, look for a parameter set, and if it's not there, we know to optimize. I could even throw controls in to delete the object ahead of time if I set a new parameter called reoptimize to 1, right? So there's a ton of cool controls I can do. The last thing I want to touch on is so far I've only been hyperparameter tuning. I'm going to leave that macro there. I've only been hyperparameter tuning my my learner, so my decision tree in this case. If I wanted to add other stuff in, like for example, I wanted to change the number of folds that I'm using, I could do that. If I wanted to throw in a smote operator, I don't know. So if I throw in like a smote upsampling and say, you know what, I want you to normalize or equalize the classes for my minority class, go ahead and auto minorities, and then increase the number of neighbors. I'm going to use local random seed on all of this just to make sure I generate the same models every time. But now I can come into this optimized parameter grid and say, okay, well, maybe I want to look at the number of neighbors and say, hey, do like 3 neighbors to 5 neighbors and see what gets me the best population set. So I think 2 steps would just be fine. And then I could go into here and also select my cross-validation and say, okay, well, if you grab cross-validation and we're going to do number of folds and just look at like, just do like start at 10 folds and go to 50 and do that in 4 steps, which should get me 10, 20, 30, 40, 50. It does. Cool. So I could hit OK, and then I could run this. Oh, I forgot to change my macro. So I can see how parameters of other operators that are maybe making effects to making changes to my training data, like my cross-validation fold size, right? I'm the larger my folds, the larger my training data sets are to learn on. And then same with my upsampling. If I'm upsampling and getting a better more balanced data set, how is that going to affect my model generation? So I added more stuff to the grid, so this is actually probably going to take longer. If I go to results, I should see these iterations climbing up. Overall accuracy is in there. Sorry, my log's kind of going nuts. But this is going to take a long time with all of those combinations, so it's not as valuable to what I want to show in real time. But I can add in those combinations to see how that's going to affect my decision tree. This makes sense because this mode up sampling is creating a bunch of data points, so it's slowing down my workflow. Just taking a longer time than I expected. Another thing that we could do right now, I'm only looking at optimizing based off of accuracy. So we're trying to maximize accuracy of our predictions. But let's say if I go into my optimized parameters grid, what if I wanted to change what I was optimizing over? So if I go to my performance classification, what I select as this main criteria here is what it's going to optimize. So right now, I'm just delivering overall accuracy. So when we see in this log, I see overall accuracy over here as the only variable. But if I were to stop this and say, okay, well, let's also deliver absolute error and correlation. What I really want is F measure, but what I probably want to do is swap this out for, that one should have been fine. Classification error, we want the binary classification. Go, binomial class, that out. There we go. So I could do like classification error area under the curve. We can look at recall, precision, and what I really care about is F measure. So if I open this up and I want to be worried about the balance of false positives to false negatives, I could select F measure. Where is F measure? There it is. I could select F measure instead. So if I were to run this, I do also have log all criteria selected. So what we'll see now in my log is I'll actually see all of those performance metrics, but what my optimized, excuse me. No, my apologies there. But what we'll see is my model is actually selecting based off of F measure. So we're trying to optimize on F measure since it's my selected main criteria here. So this performance operator is actually selecting what metric that my optimized parameters is optimizing over. So I can add a bunch of controls in. Anything that's inside of this optimized parameters grid, actually, I'll rephrase that. Most parameters of operators inside this optimized parameters grid can be optimized. There are certain objects. One that's difficult to do is with the split operator. So if I'm going to split my data to make a training and testing set, that requires me to input in a text box. Those text boxes I cannot optimize with at least with the grid. So there are certain parameters I can't include in this optimized parameters, but it is a small minority of those parameters. Anything that's a box that I need to input a range of values, check boxes, drop-down menus, anything like that, I can include in the optimization. So I'm not limited to just the parameters of my machine learning operators. I highly recommend altering anything that's affecting our training data in any significant way. So I'm not limited to just those operators. I can use different performance metrics to actually optimize over. And then if you're really creative, you could generate your own performance metric as well and optimize over that. So there's kind of limitless capabilities here in terms of hyperparameter tuning. I wanted to cover this operator because it does a lot. It involves actively logging. It trains a ton of models all at once. I can affect multiple different operators and their parameter settings. I can save that parameter set object and actually use that in my workflow as an input to the model. This also creates work. I know for most of what I've been showing in this series, I've had operators that run pretty instantaneously. These are kind of the first operators I've showed that have a progress bar because it takes so long, because I'm creating so many combinations of models, that this kind of matters. It shows how quickly I can balloon memory or CPU usage if I create enough combinations. I can, if I create enough combinations with the grid optimization, it will run forever. So that's something you need to keep track of. To quote one of my favorite Marvel comics, with great power comes great responsibility. And the optimized parameters operator is one of those great responsibility operators, because you can quickly make stuff that runs for a very long time if you're not careful. So hopefully this was a good tips and tricks on how to use this, some insight on how to be a better data scientist with AI Studio in terms of generating your models, and how to actually optimize your parameters when you're building your own machine learning models. With that, I think that's everything I wanted to cover. I know I went a little bit longer today, but hopefully I covered all the questions you guys are going to have on this, because I know this is kind of a rabbit hole. So I tried to cover as much stuff in this topic as possible, and kind of cover a lot of the stuff that I do with these operators when I'm working with clients. So I'll turn that over to any of our attendees today. If you guys have related questions or completely unrelated questions, feel free to ask. I'm kind of here to occupy this time to answer your questions and be the expert for anything that you're working on.
While folks think of questions, what I could do is launch our poll question. So I'm going to go ahead and do that. So if your screen was at maximum view, you'll have to minimize in order to select our next topic for our March session. So would you like to cover Python Learner? Would you like to review feature selection options? Would you like to review handling images? And if you select other, when you close out of the session, there will be a survey that will prompt you to give us feedback on how we're doing, what we can improve on, but then you can put a comment of another topic you'd like to review and cover, and we could add that to the voting poll box. So you'll notice that you'll only have the option to select one, so try to select the criteria you'd really like to cover. And of course, as Jeff says, right, if we miss one, you can also ask that question in the open time slot. So looks like everyone's voted. So I'm going to count down by 3, 2, 1. And by popular vote, looks like we're going to cover the feature selection options for our next session. All right, so back to everyone. If there's any questions you have, again, it doesn't have to be about today's topic. If you just had anything in general, AI Studio, running something, please feel free. If you want, you could raise your hand. We can unmute you so you can ask live, or again, in that little question panel, submit that there. Well, as you think of some questions, let's see, I can share that slide deck so you could see what is on there. So again, if you haven't had a chance, you can download. On the slide, you'll see a couple of helpful resource links, how to get a hold of our support for any questions, concerns you might have. The community, a great location to find discussion threads, as well as our documentation. The RapidMiner Academy, if you're looking to fine-tune your data science skill sets. I know it also contains some use case examples within there. Again, our Ask the Expert series will host this once a month, the second Wednesday. And again, the Academy, which is a great resource to getting certified. In the community, if you ask the question, this will go to the entire broad audience, fellow peers, experts. But if you wanted to open a ticket directly with our support, you can select the case management. Again, resources, accessible documentation, Academy site. This is all within this PowerPoint that you want to download from the handout section. If you're looking to upgrade your AI Studio, you could always grab that from the Altair Marketplace. We do have this future industry event that's coming up. You can scan the QR code. So again, kind of hear about latest trends. And then our next session will be March 12th. I know it's going to be the continuation for April, May, June. However, I will have to wait for this quarter to finish before we get the registration page updated with the new dates. And hopefully that page will be updated on March 28th. And it's the exact same Ask the Expert AI Studio web link. So I don't have anything else. So I'll give presenter back to Jeff, in case anyone's come up with a question within the client, within the product. So if there's something pressing you're trying to accomplish, you want to test out, please ask away. And again, if you want to raise your hand, we can give you the mic so you can ask, and Jeff can try to demonstrate within the client here. Jeff, I'm not sure if you're saying anything or if you're just kind of going through the...
No, I've been talking this whole time and I was on mute. I can cover, what I was getting at is I could cover some of the other things that I would do. Like I would actually create a cooler control over this, where instead of doing this optimization, I would look at pulling this. So we go to local demos. If I've already stored the parameter set, I would say, hey, pull this parameter set. And then I'm going to add a store operator in as well. I'm going to say store this parameter set there. So in the event that like maybe I have a bunch of different facilities, I'm lifting and shifting this model to other places. I'm training the same model on the same data, but the data is coming from a different facility, or I'm choosing a different KPI to model. So I'm using the same data, but I'm trying to predict a different label, basically. So I want to reuse the same workflow. Maybe I'll set up a control like this where I would say, hey, look for this object and run it. So if I have it to re-optimize, right? So I'm going to say, I guess I don't need to do it to re-optimize, but I can say look for this object and run it. But in the event that I want to reoptimize, I want to put the reoptimize in there. Yeah, I'm thinking of using a handle exception instead for this, but that's okay. But I could have it so it just like calls that. Otherwise, if this object doesn't exist, it runs the else side to train it instead. So you could do a bunch of different controls, but I could put something into, like if I want to rerun this, I could do like a delete repository entry. So I can actually delete this object. Actually send this to the front. I could delete this object first. It would cause this side to error. If this was a handle exception, it would cause this side to error, and then it runs this. So I could put this in a branch on whether or not I want to reoptimize, for example. So I could put in extra controls in here. Just some cool stuff you can do with like the branch operator or the handle exception operator, and you can remove stuff from your repository using the delete repository entry. Just some like handy triggers that you can set up to say look for an object if it exists. We can skip the optimization, but you can put in a trigger in there. So like if the object it does exist, but we still want to run the optimization, we can delete the object if I set a macro to do so. So just some extra cool stuff. But I'll open it up again, and if there are no questions, we can wrap up a little early if there's nothing else to cover as well.
For the folks that are online, you do have time to, if there's a question that's pressing you wanted to figure out, get direct free live support right now. Again, looks like there's no questions. Don't want to keep you, give you back a few minutes. I know we have this out for the whole hour, but if there's nothing that's pressing to be asked. I want to thank Jeff for his time today presenting us the topic. We look forward to next month for the topic on the featured selection options.
Yeah, it's my pleasure, guys. Happy to engage, happy to help teach and fix problems. So always feel free to come with questions, and it's been my pleasure.
Thanks, Jeff. Have a great day, everybody, and the remainder of your week. Bye now.